Hey guys, in this video we're going to go over 4 examples of graphing parabolas, and they're all going to be in intercept form. And for us, intercept form just means that the x-intercepts are the easiest things to find first. After we do 4 graphing examples, we'll take a look at 2 word problems. Our first example is y equals x plus 1 times x minus 3. And like I said before, the first thing we're going to find is the x-intercepts. Remember, those are just the points where the graph will cross the x-axis. So here's the thing, I don't know what the x value is going to be. It could be any positive or negative x value, or maybe it's 0 right in the middle. But wherever the x-intercept is, I know what the y value is going to be. Because here we have all positive y values, and going down we have negative y values. But if the x-intercept is right in the middle, I know that the y value is going to be 0. So when I write the coordinates for the x-intercepts, I know that the y values are going to be 0. So let's look back at the equation, and instead of having a y value here, let's just replace it with a 0. So I'll write 0 equals x plus 1 times x minus 3. Now I remember last unit that the zero product property tells us that we can just take these factors, split them up, and set them equal to 0. So I'll write x plus 1 equals 0, and x minus 3 equals 0. And that's how we solve an equation that's set up like this, like 2 things multiplied together equals 0. So now I have 2 simple equations to solve, x plus 1 equals 0. In order to solve that, I would just subtract 1 from both sides, and I'd get x equals negative 1. And over here I have x minus 3 equals 0, so I'd just add 3 to both sides, and I'd get x equals 3. So there's the values for the x-intercepts. So I'll fill in negative 1 and positive 3 here, and then plot those points on the graph. So negative 1 comma 0 is right there, and 3 comma 0 is to the right. The next thing we want to take care of is the axis of symmetry, or the line of symmetry. And that's because these parabolas are symmetric. They have the same thing on the left and the right side of them. And right now I have the 2 x-intercepts at negative 1 and 3. So I know the axis of symmetry is going to be somewhere in the middle of those 2 points, like perfectly in the middle. And these points are pretty close together, so it's pretty easy to see that from this x-intercept on the left, if I just go in 2 units, and from this one on the right, if I go in 2 units, they meet right in the middle. So the axis of symmetry is going to be at this point where the x value is 1. And we usually represent the axis of symmetry with a dotted line. And since that's a line, I have to write this as an equation, so I'll write x equals 1 for the axis of symmetry. And now that helps me because the vertex has to be somewhere in the middle of the parabola as well. So somewhere along this axis of symmetry is where the vertex will be. Now I'm not sure if it's going to be up here or down here, but I know that the x value will be 1. So I'll write 1 comma something, and now I just have to figure out the y value. And to do that, we'll come back to the equation again, but instead of filling in 0 for the y value, now I know the x value is 1, so I'm going to plug 1 in for both of these x's. So I did that over here, and you can see that instead of having x's written in the equation, I have just 1's. So if you think about order of operations, the first thing is parentheses, and 1 plus 1 is 2, and in this set of parentheses, 1 minus 3 would be negative 2. And the next thing would be to multiply these 2 values together, because it's just 2 sets of parentheses with nothing between them, so that means we're multiplying. So 2 times negative 2 is negative 4. In other words, the y value for the vertex is negative 4. So on this dotted line, I'm going to put a point at 1 comma negative 4. So down 1, 2, 3, 4 puts us right here. And now that we have these 3 points plotted, I can just connect them with a U-shape. Alright, let's try the same thing on the next example. So there's a few things that are different about this one. First of all, it doesn't say y in the beginning, it says f of x, but that's pretty much the same thing. Basically, this is just saying that the x values are the inputs, and f is just the name of this function. The other thing that's different is that we actually have a negative 2 in front of the 2 sets of parentheses. So we'll see how that changes what the graph looks like. But just like last time, we'll start by finding the x-intercepts. So remember, those are the points where the y values are 0. So I'll come over here and replace that f of x or the y value with 0. Then I'll use that zero product property again to split these 2 factors up. And I'm just going to include the negative 2 with this first one, because there's no x's out here or anything, it's just a number. So I'll write negative 2 times x plus 2 equals 0, and that's the first factor being split up, and then I'll take x plus 6 equals 0 over here. So let's solve this first equation on the left. So I'm going to distribute this negative 2 into the set of parentheses, because that's what I'm used to doing. So I'll write negative 2x, and then negative 2 times 2 would be negative 4 equals 0. Now to solve this for x, we have a couple more steps left. I have to add 4 to both sides, and that will cancel that out. So now I have negative 2x equals, and then this was positive 4. And then this is negative 2 times x. So to undo the multiplication, I'll divide by negative 2. And notice how I'm including the negative with the 2 there. and 4 divided by negative 2 is negative 2. This other one is way easier. We just subtract 6 from both sides, and we get x equals negative 6. So negative 2 comma 0 and negative 6 comma 0 are the two x-intercepts. So I'll plot those right here at negative 2 and then negative 6. The next thing is to find the axis of symmetry, and that's going to be the line located right in the middle of these two x-intercepts, and that would have to be right here, right in the middle. So again, 2 units in from the left, 2 units in from the right. So we'll draw a dashed line there again, but now we just have to figure out this value. So this is negative 1, 2, 3, 4. Now don't just write negative 4 for axis of symmetry. That's just a number, and the axis of symmetry is a line. We have to represent that as an equation. So it's x equals negative 4. Because remember, vertical lines are x equals some number. And then the last thing is to figure out where the vertex is. So remember, it's going to be somewhere on this axis of symmetry, but I'm not sure where. I'm not sure how high or how low it's going to be. In other words, I know the x value for the vertex is going to be negative 4 because it's got to be on that axis of symmetry, but I'm not sure what y is, so I'll put negative 4 into this equation for x. And you'll see on the left side I just wrote y because that's the value that we're trying to find. So again, order of operations says we should do the inside of the parentheses first, so negative 4 plus 2 would be negative 2, and negative 4 plus 6 would actually be positive 2. Negative 2 times 2 is negative 4, so I'll put those together, and that just makes negative 4. And then negative 2 times negative 4, well, a negative times a negative is positive, in this case 8. So the vertex is at negative 4 comma 8, and that's way up here. So then the last thing to do is just to draw the parabola shape through those 3 points. So notice that I'm capping these off with arrows at the end because they do go on forever, and also that the vertex is rounded. It's not going to be like a V shape. Alright, let's move on to example number 3, which is very similar to the first example except for it's x plus 3 and x minus 1. But we'll start by finding the x-intercepts, and this one was kind of confusing because it didn't list that one first. But we know that this one is in intercept form, so we should find the intercepts first. So I know on the x-axis the y value is 0, so I could write these out as something comma 0 and something comma 0. Then we just have to take the equation and fill in 0 for the y value. In this case they had f of x, but again that's the same thing as y. And then I'll write x plus 3 times x minus 1. And to solve this, I'll just take these two factors, split them up, and set them equal to 0. In the first equation we have x plus 3 equals 0, and all I have to do is subtract 3 from both sides and get x equals negative 3. Over here we have x minus 1 equals 0, and all I have to do is add 1 to both sides, and x equals 1. So the two x-intercepts are at negative 3 and positive 1. So we can fill those in, and then plot them on the graph. So negative 3 would be over here, and positive 1 is over here. Next, we want to find the axis of symmetry, which they abbreviated as AOS. And that line will be right in the middle of these two x-intercepts. So again, just like the last couple examples, we just have to go at 2 units in from the left and 2 units in from the right. It won't always be 2 units like that, but in these examples it has been. So the equation for that line would be x equals negative 1. And that tells me that the x value for the vertex should be negative 1, and to get the y value, I just have to plug that negative 1 back into this equation. In these first set of parentheses, negative 1 plus 3 would be 2, and negative 1 minus 1 would be negative 2. Again, it's just a coincidence that we keep getting the same values in these problems. So 2 times negative 2 is negative 4, and that's the y value for the vertex. So after plotting that, we can just draw our u-shape, or the parabola, through these 3 points. This problem also asks us to find the domain and range. So for the domain, you have to remember that those are all the x values for the graph, and this graph is going to go left and right forever. Now, I know it looks like it's curving to go straight up, but it'll never go perfectly straight up. It will always go slowly to the left and to the right forever. So the domain is going to be all real numbers. But the range is different because the range is all the y values. So that's like saying how high and how low does the graph go. So on the top side, these arrows mean that it's going to go up forever. So it's going to go all the way up to positive infinity. But on the bottom side, it doesn't keep going down forever. It does stop here. So this y value was negative 4. And the graph starts there, or stops there, at negative 4, and it goes up forever. So these y values are all greater than negative 4, and that's how we'll write the range. Y is greater than or equal to negative 4, because there is one point on the graph where the y value is negative 4. That's the vertex. So it's kind of cool how first we found the x-intercepts, and right in the middle of those two is where we found the axis of symmetry. Then we took that x value for the axis of symmetry and plugged it into the vertex. Then we took that y value for the vertex, and that ended up being the value for the range. So they're all kind of connected. Alright, here's our last graphing example. We have y equals and then negative times x minus 5 times x plus 1. And since it's in intercept form, we're going to find the intercepts first. So since they're on the x-axis, I know that the y value is going to be 0. So I'll fill in 0 for the y value. And now we have to just solve this for x by splitting these up and setting them equal to 0. And notice again I took the negative along with the first factor. So I'll think of this as a negative 1 and then distribute that into these parentheses. So I would have negative x and then plus 5. Still trying to solve this for x, so I'll want to subtract 5 from both sides. And that would give me negative x equals negative 5. And again, this is like a negative 1, so to get rid of it, since it's being multiplied by x, I'll divide both sides by negative 1. And that gives me x equals, and this would be positive 5. Okay, here I'll subtract 1 from both sides, and I'll just get x equals negative 1, and that's our other x-intercept. So we can fill in negative 1 and 5, and then plot those on the graph. And now that I know where the left and the right x-intercept are, I just have to find the middle of them to find where the axis of symmetry is going to be. And since they're 6 units apart, right, because this is 1, 2, 3, 4, 5, plus 1 more to go to the left, they're 6 units apart. So to get to the middle of them, we'd want to go 3 units in on each side. So 1, 2, 3, 1, 2, 3. And that puts us at x equals 2. So we'll draw that dotted line and fill in x equals 2 for the axis of symmetry, or AOS. And then we know the vertex is going to be somewhere on this line. So the x value must be 2. And to figure out the y value, I'll just plug 2 back into the equation. So I'll keep the negative in front, and then 2 minus 5 is negative 3, and 2 plus 1 is positive 3. So negative 3 times 3 is negative 9, but we still have that negative in front. Got to keep that there. So negative 9, well, 2 negatives make a positive. So the vertex is going to be at 2, 9. That's way up here. But now that we have the 3 points, we can just connect them with that U-shape or parabola. To find the domain, I'm just going to write all real numbers, because with all of these parabolas, they'll all go to the left and all go to the right forever. So at some point, they'll always hit every x value. But the range is the y values, and this one doesn't include all y values because it stops up here, and that y value is positive 9. That was from the vertex. Every other y value on this graph is below 9. So for the range, I'm going to say y is less than or equal to 9. So that's it for the 4 graphing examples. Now we just have the 2 word problems left. And we'll probably still want to sketch out graphs of these in order to do the problems, but the point of the problems won't be the graph, it'll be to interpret things about the parabola. Here it says a baseball is thrown across a field. Its trajectory can be mapped by the equation y equals negative 2 times x minus 4 times x minus 10, where x and y are measured in yards. So the word trajectory just means path. So let's think about what the path of throwing a baseball might look like. It'll probably go up in the air a little bit and then come back down. And that's the parabolic shape that we've been talking about. So when it says how far was the ball thrown, on this little sketch that we just made, that would be like this distance. Like from the first point where it starts to the point where it hits the ground again. So that means I need to figure out what this x value is and what this x value is. And those are just the x-intercepts. So to find the x-intercepts, remember we take the equation and we plug in 0 for the y value. So I'll take the first factor, including the negative 2 in front. So negative 2 times x minus 4, and set that equal to 0, and then take the second one, x minus 10, and set that equal to 0. Over here I'll distribute the negative 2 in, so negative 2 times x is negative 2x, negative 2 times negative 4 is positive 8, and still equals 0. Alright, so we'll subtract 8 from both sides, and then we have negative 2x equals negative 8, and then divide both sides by negative 2, because we're trying to undo that multiplication, so x equals, and negative 8 divided by negative 2 would be positive 4. In the other equation, I can just add 10 to both sides and get x equals 10. I know in my drawing it looks like this point was at the origin, but remember this is just a sketch, so it doesn't have to be perfectly accurate. It turns out that that point is probably 4, and then this point is 10. So if it starts over here at 4, and then it's thrown and hits the ground again at 10, we just have to find that distance. So I'm just going to do 10 minus 4, and that gives me 6. And remember it said that x and y were measured in yards, so 6 yards. The next question is how high does the ball go? So to figure out that height, we just have to figure out that maximum point, which is at the vertex. Well, I know the vertex is going to be right in the middle of these 2 x-intercepts. So if I want to figure out what's right in the middle of 4 and 10, I first want to figure out like how far these are away from each other, and remember they were 6 yards away from each other. So if I go in 3 units from each side, 3 and 3 would make 6. So if I go from 4 up 3, that would make 7. And also if you take 10 and subtract 3 to go left 3, that also gives you 7. So that checks out. But that's the x value for the vertex, not the y value. So I'm going to take that x value 7, and I'm going to plug it into the equation, and that'll tell me what the y value is. So I'll put the negative 2 in front, and then in these parentheses, 7 minus 4 is 3, and then 7 minus 10 would be negative 3. So I'll leave the 2 alone for a second and do 3 times negative 3, which is negative 9. And then negative 9 times negative 2 would be positive 18. And that's the y value for the vertex. This point here is at 18. So that's the maximum height that the ball reaches, 18 yards. This last word problem we have says, a wolf leaps out of the bushes and takes a hunter by surprise. Its trajectory can be mapped by the equation y equals negative x minus 1 times x minus 11, where x and y are measured in feet. Except we're actually going to change this equation, so just cross that out. And instead, let's write y equals negative, and then in parentheses, x minus 3 times x minus 5. So again, let's think of the path, because it says that this is the trajectory. That's the path that the wolf leaps. And I know that when the wolf leaps in the air, it's going to look something like this, basically like the baseball did. So to figure out how high the wolf goes, I actually have to figure out the vertex. So that's going to take a little bit of work, because I don't know where this point is right now, but I can figure out the x-intercepts, and that'll tell me how far the wolf leaped. So remember, those x-intercepts have y values that are 0. So I'll plug in 0 into this equation. I'll write 0 equals, and then the stuff on the right side. And then just take these two factors, split them up, and set them equal to 0. In the first equation, we can just distribute that negative in, so we have negative x, and then plus 3 equals 0. So I'll subtract 3 from both sides and get negative x equals negative 3. And this negative is just like a negative 1. So I'll divide both sides by negative 1 and get x equals, in this case, that would be positive 3. Over here, I just have to add 5 to both sides. So x equals 5. So if the wolf leaps from 3 and gets to 5, that distance would just be 2 feet. So how far does the wolf leap? That would be 2 feet. To figure out how high the wolf goes, we have to figure out the maximum height, or the y value, for this vertex. So now that I know the two x-intercepts are 3 and 5 over here, I know that the middle of 3 and 5 would be 4. So I know the x value is 4, and I'm just going to plug that back into this equation and figure out the y value. So I replaced both x's with a 4, and let's just evaluate this now. So negative will just stay in front, and then 4 minus 3 is 1, and 4 minus 5 is negative 1. All right, so 1 times negative 1 is negative 1, but there's still that negative in front. So negative 1 would just be like positive 1. So this y value is just 1. So it's a pretty small jump. He just went 1 foot in the air and 2 feet across the ground. So remember, the original equation was y equals negative and then x minus 1 times x minus 11. And it's totally unreasonable because, first of all, this is saying that the wolf leaps from 1 foot to 11 feet, which is 10 feet, and that's pretty ridiculous in itself. But also the vertex for this thing ends up being 25 feet in the air, and there's no way that wolf is going to leap 25 feet in the air. So the last question says, why is the trajectory of any thrown object concave down? And remember, concave down just means this shape, like down like a frown. So the reason why any thrown object, or in this case, even like the wolf's jump, is concave down is because of gravity. Like anything that goes up must come down. And that means anytime you throw something into the air, it's going to have this concave down shape. So after looking at 4 different examples of graphing quadratics in intercept form, we always followed the same process. We found the x-intercepts first, and then we used those to find the middle, which was the axis of symmetry, and then found the vertex on the axis of symmetry. So we always followed that same process. And then after we graphed those 4, we took a look at 2 word problems where we just used what we know about the general shape of a parabola to interpret what's going on in the problem. And that's it for this lesson.